Welcome guys, in this video we are going to be taking a look at section 7.4, which is our first introduction at a postulate that proves to us that two triangles are similar. Now when we're doing this, we could still go back and use that initial definition of similarity where we could say, alright, well I have these two triangles, let's say. I have these two triangles. I know that their corresponding angles are congruent, and then I know that their corresponding sides are in proportion. For example, it could be like, oh, this is 4, 6, and 8, and then this is 6, 9, and 12, maybe. So yes, we can still go back and use that original definition, but now we have a postulate that actually makes it even simpler for us. And that postulate, it is the angle-angle similarity postulate. So angle-angle similarity, what does that tell us? It tells us that if we have two angles of one triangle that are congruent to two angles of another triangle, then the two triangles must be similar. So all we need is two pairs of angles to be congruent, and that forces the triangles to then be similar. We're not going to run through the proof of this. However, it is interesting to see like, oh, it's no longer angle side angle or angle angle side. All we need is two angles. As soon as we have two pairs of congruent angles, we can say that two triangles are similar. So for example, down here I've drawn triangle HIJ and triangle KLM. If I know H is congruent to K, and I know that J is congruent to M, boom, I can immediately say that these two triangles are similar. I could say that triangle HIJ is similar to triangle KLM. All right, on this next slide, we are going to take a look at a proof. I promise you it's not too bad of one. We'll just see how we can work through this and how are we going to use AA similarity in proofs. So looking at this diagram here, we are given that angle B and angle E are both right angles. And our goal is to prove that AB over DE equals AC over DC. So we might be looking at the given and looking at what we're trying to prove, and they seem like two totally different things. Like what? How on earth do we get from there being right angles to all of a sudden we have sides mixed in with fractions? Well, we can note right here, this is a proportion, right? This is a proportion, and really what this proportion is telling us is that the sides are in proportion, right? The corresponding sides are in proportion. AB, right here, corresponds to DE. AC corresponds to DC on that triangle. So if we can prove the triangles are similar first, then we can easily just say, all right, well, by definition of similar triangles, this proportion must be true. All right, so we know to prove that two triangles are similar, we just need two pairs of angles that are congruent. And we were really already given our first one, right? We have B is congruent to E. We know that that's true because they're both right angles. Then after that, well, look, we got vertical angles right there. Boom. I got angle-angle similarity, so the two triangles are similar. Now that I have the two triangles similar, I can say that their sides must be in proportion. So we'll go statement on the left, reasons on the right. I'm going to try and fit this in here, guys. We will see what happens. So our first one, we are given that angle B and angle E are right angles. Are right angles. All right, and that is our given. At this next step, we should say that this means angle B and angle E are congruent. So angle B is congruent to angle E. That's really just definition of congruency because they have the same angle measure, right? If they're both right angles. If you said definition of right angle, all right, I'd be okay with that. I'm not too concerned with what you put as the reason. Okay, our third step, well, now we can say that angle ACB is congruent to angle ECD. And my reasoning for that is, well, they were vertical angles, of course. All right, now that we have two angles are congruent, we can state that the triangles are similar. So let's just make sure we match up our corresponding sides. So I'll say triangle ABC is similar to triangle, well, D corresponds to A, so D. E corresponds to B, E, and then C corresponds to C. My reason for that is just angle-angle similarity. All right, and lastly, now that I have the two triangles are similar, I can set up my proportion and say that AB over DE, that's a B. AB over DE equals AC over DC. And my reason for that is that corresponding sides of similar triangles in proportion. All right, hope this helps you guys out. Best of luck on the homework.